The device that does the transmission and reception of a digital signal is called codec. So a device that can encode and decode is called a codec, and you might have heard it with audio and video and converting between different formats. So what what a codec does is, for example, you can see in your mobile phone, when you talk you create an analog data. That means your voice is analog data, so your voice is continuously varying data. So your mobile phone has an encoder that takes that input audio and converts it into digital signal and send that digital signal to the mobile phone tower. So your mobile phone has an encoder, and at the receiver end, another mobile phone has a decoder, and that recovers the original audio signal, that is analog signal, analog data. So there are different reasons for using different techniques. So we use two types of techniques: digital signaling and analog signaling. So digital signaling is less expensive, and it has a mechanism to detect errors, the ability to detect and correct errors by using repeaters. So we use it for that purpose, and we use this analog signaling in the telephone system. So this analog signal we transmit by using the telephone line or the telephone network. So it carries only analog signal, this telephone network. So it only propagates only analog signals. So that are the reasons we use different techniques of transmission. So let's see the first part. That means by sending we want to send digital data, that is zeros and ones, as a form of digital signals. So we said that digital signal is a sequence of discrete pulses, voltage pulses, plus voltage and minus voltage. So digital signal means a sequence of discrete voltage pulses, and each pulse is called a signal element. So we have discussed this one previously. So the rate at which we can send bits is called data rate, and the rate at which we can send signal elements is called signaling rate or modulation rate. So, and it is measured in baud. So sometimes they are the same and sometimes they might be different. So here there are important factors for successful reception. This is, we have seen it previously, this slide also. Signal to noise ratio, data rate and bandwidth, what is their trade-off. So increasing data rate increases bit error rate, and increasing the signal to noise ratio decreases the bit error rate. That means by increasing the signal and decreasing the noise, we can decrease the error rate, and increasing in bandwidth allows increasing data rate. So this is common. So increasing data rate means how increasing the data rate increases bit error rate is by making a noise constant. So here, for example, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 signal elements or bits. So by doubling their data rate, or by increasing 30, so we have here 2 bit errors. So by doubling the data rate or the data size, we can incur 4 bit errors. So increasing the data rate will increase the bit error rate when the noise is fixed. So we will see this in encoding schemes, in different encoding schemes. So let's see the different type of encoding schemes in digital data and digital signals. So we have here non-return to zero level. So this is the definition for the different type of digital encoding scheme: non-return to zero inverted, bipolar AMI, zero ternary, Manchester, and differential Manchester. So we leave the rest, the B8, ZS, and HDB3 for this time, because they are the modification of this bipolar AMI and zero ternary. So we leave that one to the higher level. So we'll look into these 6 encoding schemes, digital encoding schemes. So it is easy. So their definition: so when we encode digital data into digital signals, so when you say digital data, that means sequence of bits. So 010011000011. So this is the digital data. So how to encode into a digital signal, that is a discrete voltage pulse? So there is a definition. So we take 0. When we get a bit 0, we make it high voltage level. So when you get a bit 1, we make it 0 voltage level. So by this we can encode this digital data using this non-return to zero level by simply this form of signal. When we see non-return to zero inverted, the definition is always when you get a bit 1, change the level. So we get a bit 0, so we start with a low level. Then we get a bit 1, we change the level to high. So 0, no change, we maintain that level. 0, we maintain that level. 1, we change the level. Then the next one, we change the level. So 0, maintain, 0, maintain, 0, maintain, 1, change the level, 1, change the level. So this definition for non-return to zero inverted. Then this bipolar AMI, we have 3 voltage levels. One is positive, one is 0, and the other one is negative. So bipolar AMI definition is when you get bit 0, we make it a 0 level, a constant level. When you get a bit 1, we make it a high. Then when we get the next one, we make it negative, positive, negative. So this type of combination. So when you get bit 0, it is a 0 volt or constant volt. So constant 1, we make it the previous high, so we make it low. So low or negative, then we make it positive for the next bit 1. So by this we can continue. Zero ternary is the opposite of this bipolar AMI. So Manchester encoding. Manchester encoding, the definition is when you get bit 0, we make it from high, change from high to low, and the transition is in between always. So when you get a bit 1, from low to high. So 0 from high to low, the transition is in middle. Then we get bit 0. So when you get bit 0, it is from high to low. So we change the level. At this level it is low, so we go up to the high level, then high to low. So 1, low to high. So here is bit 1. So we come to low side, low voltage side, then we low to high, 1. 0, high to low. Then the next bit is 0, so we will go up, then high to low. Then we will go up, so we are in the low level, so we have to go up to high level. So that's 0, high to low. Then we can continue like this. Differential Manchester. Differential Manchester, the definition is when you get a bit 0, there is a transition at the beginning. When you get a bit 1, there is no transition at the beginning. Then always we have a transition in the middle. So we have 0, so there is a transition at the beginning, then there is a transition in the middle always, so the next bit is 1, so there will not be a transition at the beginning, so only at the middle. So the next bit is 0, so we have transition at the beginning and at the middle also. 0 the next bit, so we have a transition at the beginning as well as at the middle. So the next bit is 1, so there is no transition at the beginning, so there is no line here, so we have only the middle transition. The next bit is 1, so we have only a middle transition, no transition at the beginning. So these are the different type of encoding schemes, digital encoding schemes.